the session time in attendance, but from today I'll ensure that it gets circulated during the session progress itself. Okay, welcome back. So I think last 2 days, right, you have been exposed to at least yesterday's session of mine and Ishan, right? We did cover ARM. Now again, just to forewarn you, it's just a flavor which we have given, right? There are different types of item sets, close frequent, right? Much more advances have come. And the great thing about Python, right, you do have, it is similar to Linux here, right? So when you have constant contributors, right, on GitHub, right? So Python has become the order of the day for ML, for applied AI. So I think that's the great advantage going on with Python. Good morning, sir. So yeah, I think with the stats enable, it's very good there, right? Because we teachers, right, we want to see constant packets back. So, and I think the afternoon's Harini session, right? Harini and Shivesh would have done an excellent job. I'm confident. They would have introduced a basic perceptron model, right? Which is a foundation for a larger neural network, deep learning, all that stuff. Which Friday session Ishan will do again, right? So intent of my session today, right? So I think you will find it classified as or called as supervised learning. So get started with supervised learning, right? A famous data mining technique under the supervised learning bracket, what we call as data classification, right? I think I will expose you to two basic algorithms, and then maybe Harini again comes and helps me out in the post 7:15 or so, right? Or for 45 minutes, and then afternoon again you will have a lab going on. Next. Okay, right. See, I think this. I think that's what the term I use, right? Supervised classification. Typically, you refer it to as a supervised learning mechanism, supervised learning technique. Whereas clustering, you will call it as unsupervised. Okay. I think for the audience who have already been exposed to this, they will know the difference. I think I'll have to presume the new audiences as well, right? So this, why is it called supervised? Right? Somewhere the word supervisor is there, right? So you have somebody who will help you in this learning mechanism, right? And that somebody is what we call, or the supervisor as you call, or as a teacher as we call in real life, right? That supervisor is nothing but my past history. So like that Amazon examples which we kept talking, right? Maybe ARM association rules as well, right? We said you have some data set, the past data, last 6 months purchase history, right? Available from which you can learn out some patterns, right? So that past data is a classical term used in ML literature, right? Is what we call as the history data, historical data set, history data set, right? Many multiple terms are there. Or precisely from a classification literature point of view, they call such data as training data. So you have some data which you can use to train the model. You train your ML model, train your ML engine, train your classification exercise. Okay, so that is what. And where did this come from, right? See, we human beings are excellent in learning from past experiences, right? And in fact, if you want to compare or pitch ourselves against ML, right? Even new futuristic experience, right? We'll be quite quick in adapting to. Right? That is where your classification may not be really as powerful, or your supervised learning may not be as powerful as your human counterpart. Okay, and that's what I'm saying also in the second bullet. Right? A computer does not have experiences, right? Yes, you can sort of simulate it with the static training data, but the moment you have an entirely new data point coming in, it becomes it cannot learn from experiences. But I think over the years they have come up with adaptive models, right? Yes, to some degree of accuracy it can do, but not to the level of a human center. Okay, so you can view your classification also as yet another form of what data analysis approach. And what is the larger focus? I want to extract models. That's what I said, learn a model from a training data, right? Okay, just for the audiences so that you get the terms right away. There are two types of data that you will encounter in a supervised learning setup here, right? One is called as a training phase, the other is called as a testing phase. Okay, right? So the training is where I have this past attendance will take care. Maybe you can by the end of the session you can got ping and unmute and talk to Mercy or control. No issues. Let the focus be on the session. What was I talking about? Problem with okay, right. So two types of data which your supervised learning mechanisms work with, right, is what we call as a training data and test data. So the training data is actually your past history, right? And just to give you an example, I think we gave several examples for classification, right? Whether an email is a spam or not. So what are the class labels there? In an email filter, which is interested in identifying emails as spam or not, what are the classes? I'm waiting for a ping on the chat. One. So you could spam or not spam or no spam, right? So that's what we call as a binary classifier. Similarly, important or non-important binary classes, two classes. Primary, secondary, social, three classes. I hope people are getting this word class label, right? So spam or not is a class label for me. Important or not is another different example class label for me. Okay. So like that in your training data, right? You will have a lot of attributes. Let's say you take an employee example, which I gave yesterday, right? So what? Employee ID, Aadhaar number of the employee, age, salary, gender, address, many attributes are there. And then the organization has constructed a training data where they are classifying each employee as belonging to lower class, middle class, and upper class. This is just a random example I'm throwing, right? Lower middle, upper middle, you can bring in below poverty line, many more examples you can bring in. Okay, just for the sake of argument. So three classes are there. I hope people are with me. Right? So in the so-called training data, what do I have? 100 records, 150 records, some decent size of data where the class label is also available. Generally, the class label is the last attribute. Generally, what does it say? The first record belongs to lower class, the second record belongs to middle class, right? So that is possibly done by with the experience of the organization, right? Some human expert is giving in the class labels for employees. Okay. So what is my objective as an ML person or as a data scientist, right? Use this data, learn some model. That is what I will say, extract a model from this training data. And what is objective? Find out the key patterns that govern each class. If age is in this range and salary is in this range and his educational qualification is this, then it implies he belongs to lower class. Some other feature set, he belongs to upper class. I hope people are understanding my lab that which. Okay. Right. So and then this model learned or patterns or decision rules, whatever names are there, right? So this model will be subject to the test data. Right? So what is the test data? If you have a similar or almost the same description as my training data, but what is missing there? The class label is not there in my test data. Right? That or how do I connect it with real? An example is 100 employees. You have learned some model, right? So let's say a new employee joins the organization, right? So after a month's time, I would want to classify him as well, right? So for this, I want to do it in an automatic fashion. One, you can do it manually. I think, let's say in a country-wide setup, right? The number of new Aadhaar seekers, right, will be really large, right? I hope people are understanding differentiate between or difference between training and testing. Testing is new input records, right, which I want to subject the learned model to and generate a. So what am I interested in generating as part of testing phase? Somebody can bring you in the chat. Let's say I have 10 records in my test data set. So what should the testing phase's objective be? Use the patterns or use the rules learned to generate what? this is the way I go with the class, right? I expect them to ping back on chat. I don't know whether it is difficult for this audience. You want to generate the class labels, right? I think that's the only difference. The training data and the test data, what is the difference? The class label information is missing in my test data set. Okay, right? And the test data set need not necessarily be the same data points as in the training data. That's not the necessity. But the schema should always almost be the same, right? That age should be there. The what you call the attribute, the structure of my data, right, remains the same. This thing is class label. Okay, right? So that is what I'm predicting. What am I predicting here? What am I predicting as part of testing phase? Class labels get predicted. Okay, right? So the output of a training data, excellent here. The output of Devi Priya, thank you. Right? The output of a training phase is a model. I think decision trees are there, decision rules are there, many things you will see. Right? Use that model and give that or give the training test data as input to the training data, and the output of the test data phase or testing phase is you assign class labels to all the test records. That is what I'm saying. The last or second last bullet. Classifier is used to predict labels for test data. Right. This is the focus of supervised learning mechanism. Next. Okay, I go through the slide, but I think this difference is generally confused by the audience, right? So this is looking like it is predicted. What data classification, nothing with prediction only, but you will also find another technique named as prediction in data mining. Right. So you have data classification. You also have another technique called prediction. What is the subtle difference when you are predicting numeric class labels? Right. Predicting the mark of a student based on the other marks. When the class label that is predicted is numeric in nature, age, salary, right? Then it is viewed as a prediction task. When you are predicting what we call as categorical attributes, right? The classes of employees, right? And should the loan be granted or not, whether it is a spam or not, right? These are what we call as categorical attributes in a data mining setup, right? So if your engine is trying to predict categorical attributes, then the choice of a data mining technique should be classification. But if it is numeric, then you can also use numeric to do classification, but it is easier to handle it using simple prediction, linear regression, all that stuff, right? You can use it for. I hope people are understanding difference. Numeric attribute value prediction, right? Or what we call as continuous values within a range, right? Then you can age, salary, marks, all that stuff. You can use classical prediction. But the moment it becomes categorical, what do we mean categorical, right? What a type of an attribute which takes values from a defined set, lower comma, middle comma, upper class, or red, blue, green, some color code, right? I think your categorical attribute you can possibly equate to enumerated data type in CA. Days of the week, right? Strings which take value from a defined set. That's a precise definition for a categorical attribute. Okay. So if you look at it, what is the objective of a classification mechanism? I think this is putting it a bit more mathematically, right? Learn a target function using what data? Using the training data. And what should the target function do? Predict the values of a discrete class attribute. That discrete is what I call as categorical, right? If it is numeric, it becomes a prediction mechanism. Okay, approve or not approved, high risk or low risk. All these are class labels. Two-step process that has been told, training phase, learn a model that has been told. So the literature, right, it also views data classification as learning from examples. Clustering, we will, I think tomorrow's session, maybe that point will come. But classification, you can call it as learning from examples. Clustering, you will call it as learning from observations, right? Learning from examples. What do I mean by an example here? What do you connect as an example with the discussion so far? The training data set, right? That is an example for me. The past history, the training data set, excellent. Archana, very good. I'm sorry if you, I think most of them are faculty, right? So pardon me if I'm calling your name without the titles, right? I think that's the curse of a teacher, right? For always, any audience is always treated as a student. Fine, I'm sorry for that. Okay, right? So fine. So the tuples and attributes, right? So that I think that understanding is sinking in. Okay, and this testing phase is what we call as live data set kicking in, right? And the best example I give, right? See, I think most of us are these days we are very happy to work from home or classes from home, right? The biometric attendance system, right? I think most of you will be aware of it, right? The moment it is installed, right? I think you swipe your finger, right? But when it is first time as it is installed, right? The office clerk will ask you to, Madam or sir, give your fingerprint, right? Your right thumb or left thumb. Normally, I might do with my right thumb. Whichever finger your fingerprints are good, right? They will ask you to swipe it twice, thrice, or 5 times, whatever it is, right? You do it once, do it another time, madam. The first type, employee employee ID 10 is relevant, and then they will ask me to give 4 fingerprints. What is just a number I'm giving you, right? That is nothing but a training phase, right? Where I'm teaching that biometric classifier that the first fingerprint is relevant. Why are they asking you to do 4 5 times, right? Because later when you test it daily, right? The way you place your finger, you can have some slight differences, right? Slightly tilted. You have some water in your hand, right? So some oil in the hand. I think I'm not saying you purposely put an oil and then fingerprint on it, right? I hope people are getting it, right? So these are 4 variant datas of me, right? 4 training records. But what is the class table? In this case, what is the class table? 4 different slight variant fingerprints of me. Internally, it goes in as an image. It later get converted to a pixel sequence. That all the stuff happens. Okay. What is the class label in this case? Excellent, very good. Match or not matching, right? But to be very precise on the categorical attribute, friend, you can either view your employee ID, right, or the name as a class. Because you want the feedback, right? The moment you swipe daily attendance, you want that Silver recorded, right? Or employee ID attendance 10 recorded, right? I hope people are getting it. So this biometric fingerprint system is a classical case of data classification network, right? Testing is what? 100 employees giving 4 fingerprints each, 400 training records. That is training for me. Once a model has been successfully trained, right? Each day's attendance you swipe or you register, right? That is a testing phase. Okay, I think it's quite a lively example which we possibly use daily life as well. Okay, next. Right? So if you look at the models, right, I think you will be I will cover a decision tree and a Bayesian classifier, right? So you look, I think this classifications, the literature has been there for a long time years, right? And one of the first mechanisms to evolve through a data classification task was decision trees, right? Why do they call it a decision tree? A tree data structure will be employed, and that tree data structure will help me in carrying out the decisions of assigning class labels. Okay. So if you look at it, the training phase, what is the objective? Learn decision trees from training data. Some of the famous classifiers to evolve. CART stands for classification and regression trees. ID3 stands for iterative decision trees, right? And then there's an iterative inductive dichotomy as well, right? And SLIC stands for supervised learning in quest. That was an IBM classifier, right? You will find several variants, right? I think it is there. The literature has been there for more than 40 years or so, right? At least we'll stick out to the basic decision tree version ID algorithm, okay? And I think just I wanted to give one more relevant example of the COVID context, right? Because hospitals are interested, right? Can I start predicting, let's say you are interested in 2 classes, high risk patient, low risk patient, right? Based on his past medical history, and what is it called in the COVID terminology these days? The past medical history of the patient. Because I got to know the term only during the COVID time. the past medical history of a patient, one term they give, right? High risk or low risk depends on age, correct? But then they also say the past medical history, right? If you are a DASH patient, you are highly prone to susceptible to COVID infection, right? So what is that past history called? With past medical history, comorbidity they call, right? Are you hypertensive person? Do you have diabetes or not, right? So what am I meaning, right? Hospitals may be interested in even predicting what is the likely high risk patients I'm going to get in the next 1 month, low risk cases, so that they can better critically manage my ICU resources. Right? Should I scale up on the ICU resources, or should I set up more ICU beds, or should I set up more the normal ward beds, right? I hope people are getting it, right? So one more example is a bank loan application, right? Based on your past repayment history, CIBIL score, lot of attributes, right? The banks, right, they can decide to either give a loan or not using a classification engine. Okay. Next. Okay, I think this is a formal pseudocode for classifier, right? I don't want to confuse people, right, with it. I will map it with a trace. Okay, next. And the beauty about Python, you will just pass a tag called some function called decision tree, base. It will go and simply classify it. Okay, right? So, okay. So the objective of a decision tree model, right? Somehow construct a decision tree. It should look like a tree, right? Which will help me in this task of classifying. Okay, right? And if you look at it as an algorithmic strategy, right? It belongs to the divide and conquer paradigm, right? 100 training records I have, 1,000 training records I have, keep dividing it into partitions, right? And each partition will relate as a class label. At a very abstract level, I'm telling, right? At the start of the process, right? The entire training data set is my root, right? And then I start employing some conditions, then the data set gets split as P1 and P2, partition 1 and partition 2. Next level, it will become P1, P2, P3, P4. Like this, I keep building the tree until some terminating condition is satisfied, right? That is what the classifying, the class leaf labels, right? All this stuff we get in. Okay, next. Okay, I think that's what I believe in, actually going with the trace here, right? Because then the understanding is much better. Okay, right? So let's say this is the data set I have, right? For the data mining aware audience, I think you will better recall that this is an example from Hanan Campbell. Okay, let's say the top one is the data set I have. Is it the class label is whether he buys a computer or not yet. The last label, right? That is my class label. Whether a student or whether an employee, whether an individual, whether he buys a computer or not. And some amount of cleaning, selection phases and all have happened, right? And they have identified that it is age, income, whether he is a student or not, and what is his credit rating. These 4 attributes have a role to play in this data classification task. How have they done that? The initial data selection phases will help, right? I think I may also touch on that towards the later portion of the session. Okay. So what are the 4 class determining attributes? Age, income, student, and credit rating. Credit rating, age again, right? It is within a range. It is less than 30 or 31 to 40 or greater than 40. Income is either high, medium, low. Student, it's a binary attribute, yes or no. Credit rating is again binary, fair or excellent. Buys computer is again binary, yes or no. Okay. So what is the objective of a classification procedure? The training phase, I mean, right? I have to generate a decision tree, right? So the first problem which the algorithm designer will face, right? There are 4 or 5 attributes. Which attributes should I start with? Okay, right? I'll teach the mechanism as to how do you order the attributes and all shortly, right? But let's assume you get some, or there is some mechanism among the 4 attributes. There is some statistical way which says age is of higher precedence. Age is the most important attribute in this data set. Then maybe look at student attribute and then we credit at rating. Right? I think in this case I'm looking at the same level. I think interpretations can be different. Okay. Sir, you are skipping that. It will come in my later slides, right? There is what I think what they call Gini index, entropy, several statistical measures which will help you to order your class determining attributes. What do I mean? Among the four, which is the highest precedence? Which should I start the decision tree construction with? After one level, what is the next attribute of interest? That is what your information gain, Gini index, entropy, several measures are there. Okay, I think one I will show you in this presentation. Okay, so let's assume I have done that. I get out age as a most important attribute. Okay, so the root of the decision tree, right? In this case, I say look at age of the training records, right? And I did say, right, age in this case is having three possible values only, right? It is either less than 30 setup, or less than or equal to 30, 31 to 40 range. The next is greater than 40 range. Okay, or greater than 40. So three types of age values are there, right? So for in this case, age is not a literal, it is a numeric attribute, but I'm actually grouping it, right? Less than 30, greater than 30, 30 to 40 and all, right? So, that is why I'm not treating it as a numeric split as we call, okay, right? So I hope people are connecting with me, right? So what is the condition I am imposing on the tree at the root level? Add a node called age, and the branches of the node, right, or the branches of the tree at this level are the possible three values for an age record. I will treat age as sort of a right, categorical attribute, right? Because nothing less than 30 in this comes. The moment you call it as a continuous attribute, right, it's a witness, range, right, numeric value only. Essentially, it is numeric agreed. But the moment you have it as coming from a fixed set, because you are not interested in the precise value, right? You can even call it as lower range, middle range, and upper range, right? So in that sense, you can view it as a categorical attributes. For all such attributes, just add the number of or the unique values possible as branches of the tree. Okay, right? So age. So what does that mean? Age can either be less than or equal to 30, or age can be in the range of 31 to 40, or age is greater than 40. Right? So paths in the tree are or conditions. Okay, we will go through first setup. Okay, if age is less than or equal to 30, right? Now we'll look at it. I think I'm giving you the example for the terminating condition as well straight away. Look at just the age. We are not getting into the other attributes now. Less than 30, how many attributes are there? First, or records are there? 1, 2. The third one is here. Correct, he's pointing there. That's it. So three attributes are there. No. Is there anything else? Four are there. Yeah. Good. I think there are four, right? If you count them just less than or equal to 30, 1, 2, 3, 4, 5 actually, correct, right? I hope I'm counting right. The screen is small for me to see. I hope I'm counting right. And look at their class labels. These 5 records, right? Are they all belonging to one class type? Either no or yes. But the question is clear. 5 records you identified of age less than or equal to 30 type. But the problem for you here is all 5 are not belonging to the same class type, right? They are not all of type no, or they are all not of type yes, right? So I think that is an S. So Santosh is pointing, that is an S, and you pointed a no. So this is the problem, or this is the iterative nature of the decision tree, right? So I am not able to uniquely classify records just by looking at age as less than or equal to 30 alone. If it is a mixture of class labels at a level, the tree construction doesn't stop, it iterates, right? That is what I mean by growing the tree along the leftmost path. I hope people are clear. Less than or equal to 30, there are 5 samples, so I cannot stop there. 5 samples which are a mixture, right? So I cannot stop there. So next, what do I do? Look at the next attribute in the ordering I have, right? I think both student and credit rating are of equal value, right? Let's say I go with student. Okay. Are people getting it? And what is the implied within a path in a decision tree, is it an or an and condition? Age is less than or equal to 30, and is he a student or not? Okay. Now look at it. Less than or equal. Let's say bother about no. Okay. Age less than or equal to no is class label no. Similarly, next is also satisfied. Where all less than or equal to 30. This less than or equal to 30. Student no, right? And less than or equal to 30. Student yes, it is yes. I hope people are getting it. So the moment I attach the student attributes value, right? Right. Now it fits into, I think it is 3:2, right? I hope I'm right on the count. So with both these conditions in place, I will get overall 5 records, but 3 records belonging to the yes type class label and 2 records belonging to the no type class label, right? So my condition is getting satisfied, right? So at a level in the decision tree, this is what we will call as leaf level. His student is equal to no, that yellow colored box here, and his student is equal to yes. The bottom, the pink and the green labels, I view them as leaf nodes. Okay. When do I view it as a leaf? If the collection of records at that level in the tree, if they are all belonging to the same class label, then I can stop growing the tree along that path. Is that clear? I hope people are with me so far. Are people clear with the leftmost part of the decision tree? Good. And I think that is very important a little bit. If you have any issues, you can ping me on the chat. Right? See, what is the terminate? Look at the, okay, one more example. The next path in the tree, right? The 31 to 40 range, starting from age, right? Look at 31 to 40, right? So go to your training data set. 31 to 40, how many records are there? 1, 2, yeah, I'm repeating it. 1, 2, 3, 4, right? So there are 4 records in the training data set which carry the age value 31 to 40. Look at the class labels, all are yes, right? 1, 2, 3, 4. I hope people are getting it. First condition I'm checking over the training data set is age that's 31 to 40 range. And fortunately for me in this case, all the training records in the range of 31 to 40, they are all belonging to the yes sample. Right? So these 4 records at least, I don't have to learn anything more because I am getting some certainty, right? If it is age in this range, then it is always yes label. Right? So that is why I am stopping the tree. I am populating the leaf node as yes, right at that second branch in this tree. Is that clear? When do I have to grow further the tree? The left path, right? Why did I have to go and look at student? Because at the end of the first condition, I had 5 records, but it was a mix of both two no samples and 3. Santosh, you can correct me if I'm wrong on the count. 5 records. The leftmost part I'm telling. Why did I have to go and grow the tree to the second level? Why did I have to bring in? Why did I have to bring in student? Because the earlier level, it is a mixture of class labels that is not accepted as a terminating condition in addition tree nectar. Okay. When can I stop growing the tree along any path? Some level, the leaf level, if you are treating it as leaf level, they should all belong to the same class label. The middle path, I'm getting the condition, I'm stopping it. Right? The leftmost path, I didn't get it, so I grew it with student. The rightmost path, if you look at greater than 40, Santosh, you can point there, greater than 40, so far, yes samples. Yes sample. I think 1, 2, how many? 1, 2, 4, I think. 4, 2, 2, I think, right? I'm missing on the count, you count it later here. Okay. Unfortunately, the age greater than 40 range, right? It is again a mixture of class sample. So I can't stop it at that level, grow it further, right? See, this is actually the final decision tree here, right? So it is almost an optimal version, right? You could have gone looking at student as well. You may terminate or not. Let's assume I choose credit rating, okay? Because one more attribute is there, right? Greater than 40, credit rating possibilities are fair and excellent, right? Greater than 40, when it is fair, right? It belongs to yes. Yeah. I'm coming there. I'll answer this. Let me complete this phrase. Okay, excellent question. Very good. Where did I stop? Greater than 40, when credit rate is okay, I'll put it this way. When the credit rating is yes, in that path of a decision tree greater than 40, I think it is always an example, right? When it is excellent, it is no, I think. I hope I'm right. Santosh, is it right?
Yes, sir.
3 plus 1, I think, right? Good. I'll tell you why we take it shortly, right? Excellent and fair. They are splitting as 1, 2,
So
3
two
is to
excellent were there.
1. Greater than 40, excellent. Greater than, oh, okay, fair and excellent. It is yes. When it is fair, when it is excellent, it is always no, I think, right?
Yes,
Good.
sir.
So 1, 2, and how many are in fair categories? 31, 40, 1, 2. Correct, right?
Yes, sir.
Okay. So I hope people are getting it, right? So the moment I bring in credit rating into that respective part of the decision tree, right? So let's say it is 4 or 5 records, whatever you count. In this case, I stop growing the tree because the class labels that each cluster, that each leaf node level, right? They're all belonging to the same category of either yes or no, right? And let's say you don't get this condition, which can theoretically happen given a data set. You will build it using the next attribute, let's say income or student, right? You can keep building the tree, right? And let's say you have gone for some 100 iterations. I am not getting this. This is what we call convergence here. When can I stop? Right? I am never reaching the convergence criterion. This is just a theoretical case I'm putting. Right? So at some level in the tree, right? Let's say I'm having 50 records, of which 45 are yes and 5 are no. Right? 90% they all belong to the same class label. Only 10% they are of the other label. That's a call to the designer, right? Because how long can you keep waiting for convergence, right? The 50 is a small number I'm giving in. Live examples, this can be even be 500 records where 450 are yes and 50 are no, right? So in such cases, when you reach, you go for what we call as the statistical concept of majority voting. Okay, what does that mean? Because predominantly majority is 45 in that part of the tree, treat the others also as belonging to yes. You don't do it straight away after some amount of iterations, some 50 iterations, some 10 iterations. That's algorithm designer's choice. Okay, so I hope people are getting this concept of majority voting. Right? I mean, I'm not able to decide one way or the other. I should take some meaningful call, right? So that is why I'm taking a call on the majority dominates, right? That in statistical principles is referred as majority voting. Okay. Santosh, is my fan noise disturbing?
No, sir.
Fine. Right? I think people have got it. If you look at it, right? 40, I think this is a 14th record trading it as that. The bottom level leaf labels, if you count, Santosh, you can point there, the bottom level. 1, 2, 3, 4 leaves at the last level and 1 intermediate leaf. What is that? 1, 2, 3, 4. Totally 5 leaf levels you have, 5 leaf nodes you have. If you count all the records, add up, right, you will get, what is the number you will get? I'm yet to answer Anuja's question. I'll come there. That is one complete phase we'll do. Is the question clear? If I count the number of records at the respective leaf nodes, what is the count I'm likely to get in this? Yeah, you are meaning the leftmost part. Good. Do it similarly for all the paths. you will get the 14 training data set size here. I hope people are getting it. The yes, the intermediate, how many were there? 31 to 40.
4, sir.
5 plus 4 is 9. And the last part is again 5, I guess, right? So 5 plus 4 is 5. Right? So that's because you don't want to leave out learning a pattern from any record or any data point from the training data set. Okay. So I hope people are getting this. Now to answer Dr. Anuja's question, could not get this. Okay. And I'll just repeat. See, the leftmost part in the tree, right? And then it bifurcated as 2 eventually. No and yes, I think it was a ratio of 2 to 3, right? 2 no records or 3 yes records. Exactly, you can connect it, right? So there are 5 records in that less than or equal to 30 part alone, right? And all that 5 with the student again, it becomes unique, right? The class tables are not overlapping, right? At the bottommost layer, the 2 were all belonging to the same class table, yes or no. Similarly, that yes was 3 or whatever was it count, or take that second part, 31 to 40, all 4 were belonging to the yes sample, right? So you stop growing the tree. Similarly, on the edge path on the right side, right, greater than 40, the bottommost leaf if you take, right, at this level again it was a combination of 3 to 2, right? So totally 5 records at that path. I hope people are getting it. A decision tree is nothing but a partitioning of my original data set such that at leaf nodes I have all records belonging to the same dash. Can you fill up the dash for me? Yeah, that is okay. No, that is the duty of a teacher. No, thanks. I'm expecting you to fill up the dash. A decision tree model is nothing but a partitioning of the data set such that the learning is complete when at the leaf nodes, the records, they are all belong to the same dash. Or data points at the leaf level, they are all belong to the same what was that overall yes and no you brought into the training data set here? They are all belong to the same class level. Very excellent. So that's the terminating point in a decision tree builder. Keep splitting it, keep growing the tree until you reach the condition that a sub-partition, right, of smaller set of records you get, they're all belonging to the same class table type. Any amount of iteration I'm doing, I'm not getting it, then you go for majority voting. But you don't do that initially. That's what I said. Minimum 10 iterations is a decent number to build a tree. Okay. The 10 iterations means somewhere the tree is building at 10 levels, right? So that's a decent number to call to take. Okay. Now to answer, I hope it was Dr. Anuja's question, right? Who was it? Right. Why did you conveniently? It was a valid question, right? At the second level of the tree, right? Why did you conveniently chose? You can even bring in student as well instead of credit rating, right? You are free to bring in student as well. Let's just for the sake of theory, let's say you do student, right? What was that? Greater than 40 part. Greater than 40, right? Student is no and yes, sir. Right? I hope people are getting it. Student is greater than no or yes. Both are belonging to yes, sir. Right? So you may not get that terminating condition quickly with the student there. That is why I said this is the final decision tree output, right? The optimal decision tree as we call, right? If you chose student, you could have done it. Maybe you may not have terminated, and then you would have brought in either income or credit rating at the next level. I hope, who was it? Okay. I hope the question is answered. See, there is nothing wrong in doing that way, but your decision tree will be a bit more longer in height or lengthier, right? And you should bother about termination. Okay. And a lengthier decision tree, what does it mean in terms of the application time? See, if your tree is too deep, right, then it means to classify a test record, it may take more time. Are you getting it? Because I have to go and look at more deeper in the tree. Okay, just for the audience's question. Let's say I have the sample, right? Age is equal to 25, income is equal to high, credit rating is equal to fair, and the student is equal to no. Right? So this is the test record. Let's say I get new sample test record. Now what do? You subject you go to the decision tree. Age is 25. So he is in the leftmost tree path. Income you don't have to look at there. You just go and look at student. Student is no. So what will be the class label you will assign? Excellent. This is what we call testing, right? So why did I bring in this testing mechanism? Right? The deeper the tree is, or I mean height of the tree, when will the tree become long? Too many nested conditions you keep bringing in, right? Age, student, income, education qualification. Let's say in some cases it may come. Then the classification time will increase. Okay, right? I hope people are correct. Okay. So I hope people have understood the larger application picture, right? Next slide, part. Right. So this is what, right? So, but then you have not told the formal way of how do I evaluate the. We wanted to order the attributes, right? Gain ratio is 1. Next slide. Just show me there. Gini index is 1, right? And I think one more may come. Next slide. Okay. Earlier slide you stick on. Earlier slide you go. Right? So there are various information gain measures here. Right? What does that information gain mean? What from an attribute, if I take, let's say I take what is a student, how much amount of information will be conveyed by this student attribute to my mining procedure, or how much amount of information is conveyed by this student attribute or credit rating attribute with respect to my training data set. Okay. Right. So this is what we eventually calculate as gain ratio, right? Gain ratio is defined as gain of A by split of A. I think split information of A, right? I'll quickly say what does that mean, right? The capital D, right, is my original data set here. Okay, right? And how am I partitioning it? With respect to class labels, right? There are actually 2 class labels of interest, right? Your no samples and yes samples, right? So if you look at it overall, I think let's assume how many, Santosh, can you count the overall no and overall 1, 2, 3,
I know,
4,
sir.
5. Okay, 5 no's, right?
Yes, sir.
Correct. So in this you have 5 no records and
9 yes.
9 yes records. Okay, thank you. Go there. Right. So that denominator, right? So what is that? J is equal to 1 to 2 here because the number of class labels are 2, right? So cardinality of D1, what does that mean? Let's say no is 1 and yes is 2, right? So what does that mean? 5 by 14 log 5 by 14 plus 9 by 14 log. I think I'm doing it for income here. Okay, I just know whatever I said was with respect to the class level. Okay, right? So I think you can compute like this, right? You will get the attribute to the maximum gain ratio. Right? See, for okay, just show it to us for income once. Okay, we'll do it for income because the example is carrying it for income. Santosh, go there. Income, if you look at, right, how many possible values are there? There are 3, right? High, medium, low. Okay, go there. Go there to the formula. See, that is why the sigma will run from J is equal to 1 to 3 for income. Okay, look at it. there are three summation terms, right? Outer there is an overall minus in the formula. Right? I'm not getting into how the formula came and all. That's a big one-level lecture here, right? We'll stop that here, right? So look at it. Out of 14 samples, what was the income value? Low, medium, low.
So 4 high, sir.
High, medium, low, right? So
Yes,
look at income 1, 2, 3, 4.
4
There
high.
are 4 high values. 1, 2,
6 medium,
3.
sir.
Good. Go there. 4, 6. The rest is 4. Okay. Next. Right? So out of the 14 sample records I have, there are 4 high values. So that is first. So 4 by 14 log 4 by 14. Next the 6 medium. 6 by 14, 6 by 14. The left out is low, whatever it is. Right. This value I compute, right? That I get as 1.557. Right. The gain ratio with respect to that income attribute is defined as the overall information gain that I get divided by this salary gain that I get, or salary gain, correct, salary attribute, right? So this 0.029. Next slide. Okay, I think this is, I'm taking another measure. Okay, right? Go there. The first example I told, right, where it was 5 by 14 log 5 by 14 and 9 by 14 log 9 by 14, right? I hope people are getting it. With respect to the overall data set, I'm not looking at any attribute values and all. With respect to the class labels alone, 5 yes records and or 5 no records and 9 yes records. Those are the two possible values with respect to the entire data set. So the gain from that class label overall is some, if you substitute this in the formula, right? Minus 5 by 14 log 5 by 14, again a minus 9 by 14 log 9 by 14, right? That you will get it as 0.029. Okay, and then if I factor in information, what salary, that I get as 1.557. So what is the gain I will get on information with respect to salary if I bring in the data set? It is 0.019. Okay, you will have to do this for all attributes and then whichever maximizes. I think for that example, age carries the highest here. Right? If you are fortunate enough, age is the highest, then the next highest salary, right? If you get a proper ordering, then you can go building it in one. You don't even have to look at the breadth way, right? But let's say some two attributes are carrying the same gain ratio, right? You can end up that, right? Ideally not possible, but if you even get it, right, then you can what view as growing it at the breadth level. Go to the tree so that they connect height to the depth. Right? See, this is what I mean by growing in the depth level, right? Age, right? Student. And let's say I didn't even terminate. In this case, I'm terminating theoretically, right? Just say if you're not terminating even in this part, right? Then maybe look at income. You will build, that is called depth first growth. Okay, right? But I think in this case, student and credit rating you can assume as carrying the same importance. That is why they are in the same path of the tree, right? So you can even bring in student again at the rightmost path, nothing stops, right? You can repeat any number of times the conditions, nothing stops. But again, at least I'll pitch the question this way. When you add a new node in the tree, internal nodes, okay, what are internal nodes? Santosh, you can point to the internal nodes. Student is equal to no or else, age is equal to the 30 or not, 31 to 40, and they're all called as internal nodes in the tree, right? So when you add an internal node in the tree, which is nothing but a condition which I add, at least my classification accuracy should increase. Number of mixture of samples should keep coming down. Okay, right? I hope people have got it. Right? And I think you will have support for the testing various measures, right? I think see, why is it called as an information gain attribute? What is the amount of information that I can get it, with respect to the class label. If I just look at income over class label, what gain I'm getting from that attribute, that is what we call gain, information gain. And because it is one gain divided by the other gain, we call it as a ratio. Okay, next slide. I think this formula is then you have traced it, right? I think ideally you should do it for the salary or income is then age, student rating, all that stuff. Okay, next. Right? So like this, there are plenty of terms here, right? Gini index is the different measure, right? If you're not getting good convergence with information gain, you can go in for Gini index, right? There's something called entropy. Next slide. Yeah, I think this is one example for Gini index here. Okay, right? But I think you don't have to pick up all possible in the first setup itself. Okay, right? If you understand one, then maybe you can go for uh, other setups as well. Okay, right? So we will stop there from this algorithm point of view. Next. Okay. So at least I have done from a. I hope people have understood the overall classifier model for decision tree. Okay, right? Okay. Let's say you have constructed a decision tree. How will you express the output in a program? See, I don't have time for the waiting for the answer. Right? A decision tree can also be viewed as nothing but a set of if-else rules here. Right? Correct, right? If age is less than or equal to 30 and student is equal to no, then class is equal to. I hope people are getting it. The multiple paths in the decision tree, as a programmer, can simply view it as an if-else condition. Correct or not? Are people with me in this point? Each path in the decision tree is nothing but a sequence of if-else, right? So that is why you even call that the knowledge of a decision tree or the output from a decision tree is nothing but decision rules. Okay. The whole challenge of learning is how do I arrive at these points, right? I think that the procedure is really deep when it comes to numeric attribute split and all. Okay, right? But I think that will be taking too far in a first level discussion itself, right? Because you should get an application player. That's the whole point, right? And there are plenty of alternate ways of doing it as well. Okay, right? So I'm assuming people know how to test it, right? So you will subject your test record to such rules, you will get the class label. Now, is my classifier accurate or not? Okay. Or what is this called? You had this interesting measures concept, right? For your ARM, it was confidence. For class, is my classifier accurate or not? That is what I call it as a predictive accuracy, right? So you look at the formula at the top. Total number of test records, let's say it was some 50, out of which number of correct classifications, right? Let's say out of 50, 40 records were correctly classified. Then 40 by 50, 4 by 5, 80% even classification accuracy, right? But now your question will be, how do I know whether it was a correct sample or not? Okay, that is why what we advise is, if you have 1,000 records in your training data set, right? Take randomly 800 and learn the tree from that. Okay, keep the other 200 as your testing sample. 200 is normally it is 80-20 ratio here, or you can even go in for a 60-20-20 in a different setup. But let's assume 80-20 ratio. Okay, 80% of records will be used for training, 20% for testing. So why should I what segregate the data set like this? See, in my training data set, these 200 records, the class label will be available, right? So keep that, then remove the class label and pass that 200 records to your classifier model, generate the class label, then you can compare, right? Are people understanding this? Good. Now, why are you constantly looking at time? I want Harini to go click in for the Python equivalence of this. Another 15 minutes, yes. Okay, right? So in a binary classifier, okay, the example which we saw, is it a binary classifier or not? The example we saw, is it a binary classifier or not? Good. In a binary classifier, you can bring in more effective performance measures, right? True positive, false positive rate, all that. That's what I'm bringing in. But you should understand first the terms, okay? Right? See, it is an actually, okay, let's say positive, negative, you connect. Well, positive is an S, negative is a no from the earlier example, okay? Right? It is actually a positive sample. The system is classifying it also as a positive sample. Then it is called a true positive. You know, people are understanding the terms, right? And this actual is what we call as ground truth. In ML circles, they will call it as ground truth. Okay. Actually, it is a positive sample. The system meaning whom? Which phase? It is a positive sample actually. The system is also classifying it as a positive sample. That is called as a true positive, 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 true positive, right? But what do I mean? Which phase is that the classifying positive happening? That one answer will convey whether the understanding is complete. So you learned the decision tree in the dash phase, and then you are generating class labels in the dash phase. Testing phase, right? See, what is the interest of accuracy measure? Is the testing phase about classifying it accurately? Is a positive samples accuracy good? Negative samples accuracy is good, like that, right? So I hope people are with me. That classified positive, classified negative is the testing output. So if it is a positive, the system is also tested, or testing phase, right? It is at positive, then it is called true positive. If it is actually a positive sample and the system is classifying it as a negative one, first row here, first row, second column. Actual positive classified as a negative. Very good. That is why we say the system is falsely classifying it as a negative. Actually, it should have been classified as a positive, but it is mistake. This is where it is poor. The system is classifying it as a false negative. The other case, it is an actual negative sample, but the system classified as a positive sample. You call it as it's a negative, right? So there is something false about it, and the what was out for FP, false positive. Negative, negative becomes true negative. Okay, right? Now, why I am generally clear on this, because different applications will require different. In some contexts, you will be interested in positives, right? And in some applications, you will be interested in negatives. Okay, the best one is your medical. Okay, right? You are, I think, the only place that you are happy to hear the word negative, right, is in the medical, right? I tested negative for COVID. I tested negative for some disease, right? But in some other contexts, so what am I keen on? Based on some application, you as an algorithm designer may have to fine tune your model to increase the positive accuracy rate, the negative accuracy rate, the overall accuracy rate, all that stuff, right? Next slide. Right. Okay, I will not cover base in this session here, okay, because I think I want you to test also, right? So I will spend the time on the efficiency measures. Base, I'll bring it as part of my clustering itself, okay? Or I'll go through the slides in that, okay? So the same setup you take, there are two overall measures of interest here. One is called precision, one is called recall, okay? Precision, if you look at it, it is a true positive count divided by the true positive plus false positive count, and recall is about true positive divided by true positive plus false negative. Okay. So, or meaning of the formula, with respect to the correctly classified positive samples divided by the total samples classified false positive, which includes your false positives as well. Okay. So let's say 100 records I had, that 100 were either classified as true positive or false positive. Of which the true positives are actually only 60, then the precision rate of the engine is 60%. If you look at it, the precision is the overall accuracy of the process, okay, or the efficiency as we call, right? Recall. Where have you heard the word recall in calculator, right? Memory recall, we say, right? But what was the correctness of the procedure, proof of correctness, right? Did it, with respect to positive samples, did it really do well or not, and all, okay, right? That is a recall measure here, right? Look, the numerator is the same, the denominator changes, right? True positive plus false negative means what? It is actually a dash sample. False negative means what? It is actually a let's say the system is classified as a false negative, right? So what is the understanding with respect to the actual class label for some record it is classified as false negative, belongs as false negative for us. Then it is actually a positive sample, right? The system is wrongly classified as negative. It should have been classified as positive, right? So that is what, out of the total number of positives which should have been recalled as positives, how many am I actually recalling it as positives? I hope people understanding. You can again look, because in this example positives are of the interest, right? So that is why I'm focusing it that way. Okay, right? Are people understanding the difference between precision and recall? Again, I'll repeat it. 60% of the precision, if it is 60%, what does that mean? Out of the 100 records that were classified, 60% are correctly classified as positives. That's it. That is the precision, degree of accuracy. Recall, out of the actual number of true positives, how much is it accurate with respect to the positivity? That is recall. Okay, right? In fact, there are many more measures here. There is a never-ending list. Next slide. Okay, still 11:15. I'll go. Okay, I think one example I'm doing here. Some count. I think it is at one record which is actual positive, classified positive, right? 99 records. So that 99 is what? True positive. In terms of that, what is that 99? 99, what will you call? Count is number of records, I mean testing records. 99 records are classified as dash here. One is true positive. 99 records are, I think what Dr. Manuja Madam is meaning is actually positive, right? But it is actually positive. System is classified as negative. So I will treat it as FL, false negative. Okay. Right? We just substitute in the formulas, right? You will get precision as correct, right? Precision is what? Only one record is correctly classified out of true positive plus false negative, right? So 1 upon 100. Go to the formula there. Substitute it here, right? 1 divided by false positive. You take true positive plus false. So go there. Go to the data. Okay, what is a false positive here? Second row, first column, right? It is this is correct. This is 0, right? So 1 by 1 plus 0, which is 1 by 1, is 100% probably. Okay, right? So I think that is just a question of substituting, right? Then the algorithm designers, right? They felt, or researchers felt, both are different measures. One is what measuring the efficacy or efficiency of one measure, right? They wanted to balance out, right? That is why they came up with the measure called F1 score. Look at the formula there. It is 2 times precision, 2 into PR, 2 into precision divided by precision plus recall here. Right? Why was that invented? Right? I think there is a derivation. I don't want to get into that. Right? It was actually to give a balanced measure of evaluation for the classifier. Okay. Right? Can I trust this classifier? Should I learn another model? Right? Balance out, or it is a balance between precision and recall measure. It is actually a geometric progression, right? But I don't want to get into that mathematics and all. So you can even come F1 scores for classifiers. Okay. Next. Okay. Slide is never ending. I thought I can even finish base. That's okay, right? Are people clear with the two measures so far? Okay. Now, no, is this, we use these two terms here. Is the classifier really good? See, the classifier may be doing good with respect to positive samples. The classifier may be doing with respect to negative samples alone, right? Your earlier two measures took an overall call. No, sensitivity or sensitive is what I call as TPR, true positivity rate. Okay. Specificity are with respect to negative samples. Okay, true positivity rate or true positive rate, look at what am I doing. True positives divided by true positive plus false negative. See, the system is falsely classifying it as a negative. Right? It should have actually classified it as a. Are people getting it? No, you should show us. I think your precision formula will have a false positive, I think. Go there. At the denominator, I mean. Go to the precision formula here. You don't remember any stuff, faculty here. That's the difference. You took the overall returned output, false positive. Okay. But look at your sensitivity. Then you have to go to the R. Instead of false positive, why am I bringing? If false positive means out of the classified test records, how much was correct? True positive you took. Okay. But here, with respect to positivity alone, meaning it is actually a positive sample, but it was classified as that is also part of the positivity count, right? So with respect, I'll put overall positive is a denominator. With respect to the overall positive, what is accuracy level? That is true positivity. I think we also call it a specificity. Okay, right? Negative, false positivity rate. Okay, that is what. Divide false positives divided by, right? I think that false positive will anyway come, right? So false positive plus, I think see your true negative means what? The true negative means it's actually a negative sample, right? Falsely positive means it is it was negative. The system is classifying it as negative. That is true negative. False positive means it's actually a negative sample, but it is being falsely classified as positive, right? So if you look at the denominator of this expression, right, it is actually nothing but overall dash. Can somebody fill the dash? Negative percentage, right? So I think the literature is too deep here. You can the area of region curve. Next slide. I think that's what I said. Sensitivity is the same as true positive rate. Specificity is also called as. Many more measures are there. I'll stop here. Next slide. Is it base or what? Next slide. Okay, I think this is an. You can whatever I told in theory, right? You can plot it, right, and then measure the area under the positivity curve, right? All the stuff can be done. Is the slide ending at least for this talk?
Yes, sir. Ended, sir.
Okay. Days I'm not starting today, right? For paucity of time. But don't worry, I will do cover it. my tomorrow session quickly. I'll go through, right? So my request to you people, right? After a break, right? Harini will take over. Okay. Is Harini in the room?
She's there, sir.
Okay, I think she will. Yeah, thank you, ma.
Yes, sir. Actually, for now, I just have a 5 to 10 minute introduction, and the main lab session will be at
Very much.
2:30.
Okay. Right. So thank you, Harini.
Okay.
Right. So what I wanted her to do is so that the parallel Python for decision trees comes. Okay. I think she may have even prepared for base. Right. She can call it and show, but I will do it the explanation for base later. Okay. Right. One request to all. Right. Today's attendance, right, for this slot, I'm not going to start because I wanted to create some amount of fun activity element, right? So my TAs will post a Google form link in the chat here, right? Santosh, you can post it. 11:15, right? It is a short 10-minute MCQ here, right? Multiple choice questions, okay? Based on whatever sessions which happened till yesterday, nothing today, okay? Right? I think you can quickly recall and answer. 20 minutes beyond it won't surely take. Okay. So 11:35, right? 11:40 also if somebody wants. Santosh, can you post that link or should I post?
Sir, I'll do that, sir.
Then I post it immediately, right? So that
Yes, sir.
you have it, right?
Yes, sir, I have it.
Okay. Paste it here with the chat, right? People are mistaking your email IDs, attendance and all here. Okay. Right? In fact, I thought this also serve a proper record so that it matches to the ATAL portal. Okay, right? So enter your name, your email ID, and your mobile number very carefully. That form, that MCQ form, right? And then 10 questions, right? You will approximately get 20 minutes, much more. Okay, I think you click it. You can start answering, right? We'll keep the form open till 11:35. Okay, and Bash Mahendra and all need not do, but all the external participants, please do the quiz, right? Because I think, I don't believe in testing for such senior people and all, right? Sir, it is getting recorded, that's okay, right? Faculty, we have this party to talk, okay. Why are you pasting two here? Santosh, what is the difference between the two links here?
No, sir.
So I'm also into login, so I pasted it first. No.
Both are same, Amma.
Yes, sir.
Yes,
Yes,
sir.
same.
No, because what faculty members they should not get confused. Okay, pa. Thank you. Right. So take your time. Please don't mistake me that I am evaluating teachers or HODs. That is not my intent at all. Okay. Right. Because they want some records for me to upload later. Okay. Right. So, but I'll give you one assurance. This is just a flavor of what will come on Friday. Right. Where you will be possibly given an MCQ on the entire workshop. Okay. I will not ask you to write any essay writing questions and all. Right. So Friday afternoon we are planning an online quiz, right? This is the intent of this exercise is to give you a flare of what will come on Friday, right? So even if somebody's what negativity rate is high, true positives are low, don't worry, this will not have an impact on your that. But as teachers, right? I think people have started taking it seriously. That I'm saying it. So enjoy the quiz, right? I think you will get the score and the answer also immediately, or my TAs will release it. Okay, I will take a break. Harini will start from around 11:40 or so. Okay, Santosh.
Okay, sir.
Right, so you coordinate this, right? So that if some faculty are saying, "Sir, I'm on a slow mobile connection," you give them the time, but
Sure.
ensure that at least by 11:45, Harini is allowed to start. Okay.
Okay, sir.
Okay, then what was the
But
time I
actually,
gave? What was the time I
lab-
gave for? 11:45
yes,
was actually. Yeah, I forgot
yes,
the Mukesh, right?
Danny and
Danny and Mukesh.
yes, sir.
Okay, I
But
think Harini.
meeting is actually pretty. I think now I just have like 5 to 10 minutes introduction. Maybe you can.
Selma, Sulma.
So shall I just walk through the introduction for 5 minutes now, and then because the main thing is at 2:30 only.
சரிம்மா அப்ப என்ன பண்ணுங்க 11:40 you walk through that basic introduction,
Okay.
right? So that they get the time to do the quiz properly, because see, I think
Okay.
they are all either of my age beyond me or close to my age, right? So holding them for